Hello, Raj. Good
Hello, Mikel.
morning. How are you?
Good
Let's
morning.
go live.
Good, thank you. How are you?
Fine, fine. I've been better. I've been a bit sick last
Yeah,
days. So my voice is not very good, but otherwise I'm doing fine.
but you are in Sweden, right?
Yeah, I'm in Sweden. Yeah. Hmm?
Oh, yeah, okay, good. Yeah, the weather is cold. It's not so nice these
Yeah.
days. I can imagine people
Yeah.
can get cold.
Yeah. It's.
Good.
I was in Spain last week, and it was warmer than here. And then I think it's
Yeah,
traveling. Um,
I can
usually.
imagine.
So yeah,
Good.
today we have an interesting topic
Yeah,
for the webinar. Yeah.
it's a very simple topic, but very interesting
Mhm.
and could be very useful in some situations.
Yeah, it's shadowing or digital shadows is something that is not as hot topic as digital twins. We are gonna try
Yeah.
to explain what it means because some of our customers have started to look at that after they have created the digital twins with Simumatik using emulation models and so on. Then they come up with,
Mhm.
can we do this shadowing? And we are going to discuss what it is. Actually, we have some
Mhm.
examples.
Yeah.
So, what's the idea for today? You have prepared the webinar, so you can go through the agenda, maybe.
Mhm. Yeah. I mean, you have some examples that you wanted to show, right, for
Mm-hmm.
shadowing.
Mm-hmm.
Some
So,
videos that you said one of our customer had it.
yeah, so we can use those videos and then maybe discuss a little bit. Then you have built a digital shadow, so
Yeah,
you're gonna show it to us,
right.
how it works, how you build some of the components and so on, because
Mhm.
the audience probably wants to know more details about
Yeah,
the difference between building an emulation model and a shadow model. Uh,
right.
there is content in our academy that can be very useful as well, so probably you can point to that.
Mhm.
And
Yeah,
you will
I can.
show us the shadow up and running, I guess.
Right.
Yeah.
Yes, 100%.
So let's get started. What's a shadow? I think the best thing to explain what a shadow is showing maybe this video.
Okay.
So this is a project we did for a customer. I think it's 1 or 2 years ago. They have their
Okay.
machines, this kind of furnace machines, all over the world. They were interested
Okay.
in that case more than the commissioning part of building such a machine and so on. They were more interested in monitoring the actual machines that are installed all over the world. Why? Because
Okay.
when you are a OEM company, you have your products, your machines all over the world. You may have remote access to those machines to do maintenance or troubleshooting when something
Mhm.
goes wrong, but
Mhm.
usually that remote connection just allows you to see the PLC code, what's going on, okay, and try
Right.
to troubleshoot it, which is a bit limited.
Yeah.
In some other cases, you may have some data, process data, whatever, from that machine
Yeah.
in the other side of the world that you could
Okay.
also use to kind of troubleshoot. But they were
Mhm.
thinking, okay, could we feed a model in Simumatik with real-time data directly from the
Mhm.
PLC or data stored in a database because they have some kind of remote
Okay.
connection or whatever, and try to monitorize what's going on in that machine. So the
Right.
technician that is trying to do the troubleshooting, rather than just having access to the PLC code, can actually see visually what's going on with that machine.
That's true.
What's the position of the movements? Which are the values
Mhm.
of some KPIs or process values or whatever that can help this technician to
Okay.
troubleshoot. And I'm just gonna start the video so we can see
Mhm.
what is possible. So you can both animate the model using
Okay.
real values from actuators, encoders, or whatever, so you can visualize what's going on, as we
Mhm.
can see. But at the same time, you can visualize. This is also Simumatic. This is some components that are used
Right.
to visualize. You can do
Right.
animations and so on. So it can be pretty rich. And this is
Mhm.
what the model is showing now. Is actually what can be going on right now in real time in the real machine. And this
Okay.
is what we call
Got it.
the digital shadow. Okay.
Right. Right. That's very
So yeah,
interesting.
and this is in this diagram. If we go back to what you are gonna show us, basically shows that the digital shadow somehow connects to the PLC or whatever. Maybe you don't have access to real data. You have something in the middle because you have, I don't know, you're using IoT to gather data from a remote PLC, and then you can gather this data from the model using MQTT or whatever. But at the end, you have access to sensor data, you have access to control data or control signals, and you want to visualize them somehow. That's what the shadow is doing.
Okay.
And in my experience, or what we hear from our customers, they want this kind of shadow just to somehow add more features to, or not more features, but make other uses of the actual models they have created before for other phases of their products or machines. So you use the emulation model while you are doing the design, the engineering tasks, the commissioning of the machine. But once you have installed the machine, what happens with the digital twin or the emulation model? Doing some few changes as you are going to show you did in your model, you can convert that emulation model in a shadow that can be used to, again, monitor what's going on in the real machine. That's in my experience. There may be other use cases for digital shadows, but we can see it as well as a rich monitoring system like the HMIs you have in any machine, where you can show process data, what's going on, sensor status. Using Simumatik, you can create kind of 3D monitoring environment for your system.
Right.
So that's, I would say that is what I know and my experience. I'm not an expert, and the good thing is that with Simumatik, because it's so flexible, you can build different kind of components, and you're gonna show us what you did to create these shadow components for some of them. So I think I don't know if you want to see the system up and running or from the beginning, or you want to start explaining what you did.
You can switch to the next scene, and first I will show what we are going to see in the end. On the left side, you have a scene. You can just switch to full screen, I would say.
That's true. Yeah, great.
Okay. So what you see on my screen right now is a very basic system with a PLC in the center, and there's a power supply and 2 output cards. Why we do that, I will tell you later. And this is one beacon, light beacon, and some IOs. And on the right side on the camera, you see the same system. So this is the beacon, and this is the IO trainer. So what I did, I just took the CAD files from this IO trainer, and I built in the Simumatik this process we have explained in our course, how to build the components.
Exactly.
But I changed this component a little bit. So what is happening right now, let's try to press some buttons. So the moment you see my e-stop is released here in my real system, and all the buttons are in normal position. So when I press this first button, it actuates my output. So what is happening here? The real system is connected to a PLC. Maybe you don't see, but here is one PLC. So it is just sending the physical voltage to the PLC. PLC solves the logic and gives the output to my beacon. And this I can show you happening here. So let me just log in. So here in the main POU, you can see I have input and output status. So when I press the button, it is actuating my output, and this is turning off. So very basic PLC logic. Let's go down now. Now, if you notice my screen, this is actually shadowing the behavior. So this IO trainer here, it is reading the signal from PLC. I will tell you how it is reading, but it is actually mirroring the behavior of this trainer. So when I press now this button, you will see my digital twin. The button is pressed.
It's pressed. Can you zoom and show it closely?
Okay, I can show it with e-stop, for example. Let me do it like this. So when I press the e-stop, you can see e-stop is pressed and the light is on. Okay. We'll come to the details how the signals are tracking, but just first see the visually. Now when I release it, you can see it's released in my trainer as well. Now let's try with the second input. When I press this, it is actuating green light in my digital twin and also in my real trainer. This is just latching the output, and the stop button will unlatch.
Cool.
And very small example for the toggle switch as well. I just quit it quickly. If I move it, it will also actuate one output in my real system and digital twin.
Yep.
Now the question is how this is happening and how this is different from the normal components.
Yep.
Okay. So if you notice here now, digital twin, when I try to press the button with my mouse, nothing happened. So there's no user action. Because the user action has been replaced by the signal coming from the real PLC.
Yep.
So if I now show you, if somebody who's new to Simumatik, I will take one more button here. Let's say I take E-stop. How do you call it?
So while you are doing that, what you didn't create maybe the components from scratch. You took the normal emulation components and you kind of modify them to behave as a shadow instead. Cool. Yeah. So that means that most of the components in the library, you could modify them to behave as a shadow instead as well. Yeah, cool.
And I can show you by modifying, it's actually very easy. It makes, it's actually nothing. You just remove the ports and add an extra inputs. So now if you see here, that's my normal component. And on the left is the shadow component. So in my normal component, I can press it to actuate it, my digital twin, and I can release it. That's how it works normally. But now this normal behavior is being done on my trainer. So there I press and release. And this behavior of my real trainer is now going to my shadow component. So if you have any questions, you can ask me. Otherwise, I can talk about how the signals are traveling.
Yeah, so I guess that depending how many functions the component has, you may need to get more data from the PLC to visualize the real status. In this case, you just want to know if the button is pressed or not, the emergency stop is active or not. That's enough.
That's true.
Yeah, okay.
Here is just simple one Boolean signal, true and false. I think in all of these buttons, it's just true and false signal.
Yeah.
But if you have something analog, you can also do that.
Yeah, like in the video I was showing, we were monitoring process values. They can be analog values. Okay, cool.
Yeah. So now the question is how this is happening. Maybe you can switch to my canvas slide where I made some errors.
Let's go back.
Okay, so here you can see I have on the left side real PLC and real emergency switch and real tower light. So they are physically connected to the PLC. And now from the PLC, I take the signal out via Modbus. So I have a Modbus communication between the PLC and Simumatik. PLC is Modbus server and Simumatik is Modbus client. So I'm sending my input status. So my real trainer has these I/O buttons. I map these inputs to Modbus address and I send it to Simumatik. So if you see here, I have made one orange line and a green line. So the green line is actually the input status, which are mapped, and they are connected to one of the output module in Simumatik. Why output module? Because we need to send a signal in Simumatik to our shadow component. So when we send the signal, we output the signal. So we need an output card.
From the PLC, we read it to the model as well.
Yes. And this output card is just used for shadowing. We don't use it for anything else, just for shadowing. And then you see another orange line. So this is basically giving the output status of my real PLC. So if I actuate my beacon with a red light in real PLC, I take the signal out and I send it to the first output card, which gives the signal to my beacon in Simumatik, just so that it's not confused what's happening. So I take an extra card. So basically, this is also kind of like a shadow component because it's also just actuating Boolean signal on and off, showing what is happening on my real device. But to make it more interesting, we created an emergency stop to show how we can also make shadow components of inputs, like sensors, like buttons, potentiometers, or anything that you can imagine.
So we could say the main difference, Raj, is that in an emulation model, we need to write in the PLC to give the PLC the signals that is expecting from the machine or the system is controlling, while here we are just reading. both the
Yeah,
inputs
they're
and
just
the outputs. We can
outputs.
use any of the drivers we have, any protocol, the same way we
Yeah,
do
you
with
can
for them.
use OPC Yeah.
Yeah,
Doesn't matter. You can
whatever.
use
So
any.
we read
Yeah,
both. Yeah. So
you
I
read
will
both.
say that maybe what you did, you can start the model modifications just if you already have an emulation model, you could just start replacing all the input cards by output cards. So you read those
Yeah,
signals instead, and then you need to see which components you need to modify. The ones that
right.
probably mostly the ones that were connected to those input cards, the sensors and so on.
Mhm.
You need to modify them to
Okay.
behave like shadows instead.
Right.
So yeah, so it's you don't need to build the model, the shadow model from scratch if you already have an emulation model, but you need to do some modifications as you are explaining.
I can show you the difference in two components, how I modified that, what is the code inside both of these, just in short, I can show.
Cool.
So we can maybe switch to the scene full screen.
Yep.
And then I can, yeah. So this is my normal component. So if I show you its variables and connections, you will see there are input ports and output ports, just like a normal e-stop.
Yep.
You have to connect some wires and then you get the output. And if I select my shadow component, you will see there's only one input, shadow input. That's the difference. So
Yeah.
let's go deep inside. If I open the normal component, and in the editor, you will see we have electrical inputs and outputs. And these inputs goes to the outputs based on if the switch is pressed or not pressed. You can see the behavior here. Okay?
Yeah.
It's very simple. And the animation of the button is defined by this button frame. If it's not enabled, it is at some position. If it is enabled, it is has a different position.
But somewhere there you use the user action, I guess.
Yeah,
Is that the
so here you
press?
can,
Yeah.
right, this is the press, and that's here you can see it's a user action. User action is basically when you click on the component in the workspace. This signal pressed, we are reading here, and based on if it is pressed or it is last press, we are sending the signal.
It toggles
and
it, yeah.
changing, It toggles it. It's very simple.
Yeah,
Based on user action. And if we go back and check this guy here, here you can see there is no user action.
Yeah, and it's way
Very
simpler.
simple. It's very simple. Just one shadow input, and this is connected to a voltage signal, which is this is coming from PLC output. And if the signal is more than 20, basically, when it has 24 volts, then you just change the button.
Yeah. Okay. Pretty simple.
Just one input, one output. That's it.
That's it.
So you can actually, what I did, I just clone this component, because when you open the component, you can clone it.
Clone it, yeah.
And I cloned it, and I just removed the unnecessary inputs and outputs, simplify the code, and just give one input to change its state. And this is the same with all other components. So here as well, normally open push button.
Yeah.
This behavior also has one shadow input.
Yeah.
So this I forgot to delete. I'm just using one shadow input. And based on that, I'm changing its state.
That's cool.
I think any of the shadow component that we create would have only one input. Could be either digital or analog.
Analog, yeah.
And based on that, you can see how you can move it. This is what I would understand when I was creating the system.
Then when it comes to the PLC in Simumatik, you see the signals as well there in the LEDs. So when you are running, you will see what is actually on and off, exactly the same. So this is telling you which inputs and outputs. Even if both are outputs in Simumatik, it's telling you the status of the signals. So I guess that when you press the real button in your lab, the corresponding bit in the
this one.
it's gonna be switching on. Yeah.
So I can explain you how the signals are flowing. So in my real trainer, I can open the PLC program now. So I'm using a Schneider PLC, which is the very basic model of Schneider PLC M221. And this is the programming software, which is called Machine Expert Basic. It's a free software. People can also try. And here, my physical input address is I0.1, I0.0, 345. So when I, for example, press this button, this is my physical address.
Yeah.
Now I0.1, how this is going to Simumatik, I can show you here shadow POU. So when I open this, you can see I0.0. I have to reduce the view. Here, all the inputs are giving a signal to coils. And these are the coils. I can move it now here. Maybe I can make it bigger. These are my Modbus coils.
You have to map. You have to map them to Modbus because you don't have. Is the way you read and write. Yeah.
Right. And this address, when you see here after n, it's 2. This is the Modbus address. And this 2, you can also see. So when I stop the emulation, and my output address is 2. This is the address I have.
The second register, yeah.
Yeah, so whenever I actuate something in the PLC, this will actuate the Modbus output coils. This is what I read in my output card here. And this is then triggering the shadow components. So I can show you one more example. Right now you can see, because of E-stop, this is NC and this is MC, you have 2 outputs through this one. And here you can see out 0, this is 24 volt, and out 4, or out 3, this is 24 volts. And now when I actuate my toggle switch, you can see out 5 is true, and here out 5 is true. And this out 5 is connected to this toggle switch, which I can show you now here. And here you can see out 5 is connected. So it is getting 24 volt. And this is its shadow input, which moves it like this.
So even if both cards in Simumatik are output cards, the one on the right, that's the input card, while the other one is the real output card in the PLC.
Right. So the other one, how I'm mapping, again, I come back here. I have a mapping output POU. And here I have my normal output, Q0.0, 1, and up to 6. They are mapped to register 1, M1, M2, M3. And that's the register address I have in my other output card.
One thing, Raj, can you use, because you are mapping bit by bit in the PLC, you could map the entire word, right? Could you map?
I think I can do
if
that.
You do a move, if you do a move from,
I think we can do that as well.
QW0 to the.
For me.
But I guess it will be possible.
It should be possible. I was not sure about the addresses before. I just did a play around and test the system to work around with it. But for sure, this will make work much more easy. And I mean, there's not a rocket science here. It's very simple input-output addressing. And this is how I took the approach to shadow the components.
I think it explains the basics, the idea that based on maybe some components or maybe a system that you already built in Simumatik to emulate your real system, and you do the virtual commissioning, then you can just take that, clone the system or whatever, and start modifying it to build a shadow. And the cool thing is that we could talk about that now. If you go to the generic PLC in Simumatik, you have an IP address there, I guess.
Oh yes, that's 100%.
And that's the cool thing. Let's say you have not just one lab, but you have 100 labs with 100 different IPs, which you have access to. So if you would like to monitor or shadow another lab, you just need to change the IP address there, and then you will be monitoring a completely different hardware. No,
that's right.
The same equipment, and that is what I meant. I was trying to explain before with this company that have their furnaces all over the world. I mean, if the machine is similar, and you have a lot of copies of that machine all over the world, you can have just one shadow model, and whenever you want to monitor or shadow what's going on a machine, you just need to change that IP address, and suddenly you will be seeing what's going on in real time, which is quite powerful.
Yeah, that's true. I mean, you can replicate. That's the powerful feature of digital twin. You can make easily copy paste and have multiple machines as well to monitor.
Yeah.
And this makes works easy, and you can easily remotely monitor anything that you like. I think it's just one-time development time to develop this component, and then you can save this component and use it over and over
Yeah.
again
Yeah.
for different purposes. So I think we don't have much shadow components. If you like, I
No.
can publish these few of these components if
Yeah.
somebody wants to play around, or I can also make the system public.
Yeah.
And I anyways have the PLC code already in the on the system asset. And interesting part is you can also, I don't know if it makes sense to use PLC simulator if somebody don't have a real PLC to play around with
Yeah.
the
Yeah.
shadow
I mean,
component.
it's
I think this you can also do.
you can do it. I mean, in theory, you could have a digital twin, emulation digital twin connected to the PLC, and at the same time, another instance of Simumatik running the shadow
Yeah,
to show
yeah.
what's going on in the virtual
That's right.
model. So
That's true.
that's possible. If you have several computers, you can have one running the emulation model and the other running the shadow, just to validate that your shadow
Yeah,
can show what's going on in
that's
the
true. That's true.
in the model or in the system that the PLC is controlling.
Yeah,
One thing
that's right.
I think we need to mention is that this is not a completely new topic. Actually, in the academy, we have a chapter when in the course related to component creation where we talk
Yeah,
about visual components. I don't know if it's visual components or
yeah. I think it's
decoration or no. Now we are gonna
visual. I will check. I will check. Visualizing
visualizing
component, right?
component. So basically, the
Okay.
idea is taken from here. These are these
Yeah.
different kind of components that are used to show process data, status, or whatever from real PLC. In some cases, we use them in emulation models as well, but to show more data than just signals. But the idea is taken from here, and I guess there are good tricks and ideas in this course just to show how you can visualize text, how you can visualize change color of different things,
Yeah.
and so on.
This is explained in the course. Anybody can just go to Academy and sign up for the Academy for free, and they can watch these courses right away. So here you can see here I have this whole chapter, introduction to visual component, introduction to analog visual component. So I built a LED indicator as well. So I talked about both digital and analog visualizing component.
Cool.
So yeah, this I think we can also add this webinar in this section,
Yeah.
just underneath the shadow component, and then somebody can also have the access.
Yeah.
Yeah, I think this webinar has not too much to talk about. This topic was actually very easy and short.
Yeah, but it's been something that it's been something that we've been asked several times. So it was an interesting topic, and it doesn't need to take 1 hour every time we talk. We talk a lot. So I think this may open new ideas, and because sometimes people talk about digital twins and it's not very clear what they mean, and if they really want to have just a monitoring system or shadowing system of a real machine, or they want something completely parallel, that like we usually do. So we can leave it here, I think. Let me check if we had something else in the slides. I don't think so. I can do this. Yeah. And do we have any question? Do you know? We have some people viewing the webinar.
Okay. Okay. They can feel free to ask questions if you guys are viewing it. If you want to have any question regarding the seminar or regarding Simumatik, feel free to ask it.
Yeah.
I think we can also discuss about what could be the next webinar, because I heard from one of our colleagues that we should do something with Siemens.
Yeah.
And
we have the universal robot webinar as well. That I think is super interesting. The one that our colleague, our colleague Ragnar, we need to invite him as well, because to that webinar. He has been working with the universal robot the last weeks. We actually just released all the models of the universal robot robots.
Okay.
So I think, if I'm not wrong, all of them have been published, and we have the old ones and the new ones up to the biggest ones.
Okay.
So
Okay.
it could be interesting to show how we like to work now with the Dockerized version of your sim, and how easy it is to program with your sim, test the robot program in Simumatik, and most importantly, how you do the connection with a PLC, because it's not very often you just have the robot controller. You usually have more
Right.
stuff, and you want to show how is the interaction, how you build. I see many small system integrators that just do small robot cells with just universal robot, because it's a very nice platform with just some simple PLCs, and they build these palletizing robots or pick and place robots and things like that. And I think for them, this kind of webinar can be very useful to show them, okay, how easy it is to connect your sim with Siemens, Rockwell, Omron, any PLC you want, and build a very easily a robot cell.
That's
so
right.
I will.
We have this URSim tutorial in our academy, but this was done when URSim was running on Linux system.
Yeah.
And then you have to run a virtual machine, and this was a bit complicated to connect Simumatik, although it works.
Yeah.
But now with the Docker, it makes it very easy, because you are not dependent on the OS. You can just run the Docker container. I also played around a little bit, and just open the port, and then it has a very nice user interface which you can run on the browser. So you can see the robot panel, and then you can program the robot there and connect with Simumatik just using one port address.
So let's see. We have some ideas for a Siemens software related webinar. This one with your sim.
Okay.
Even if this webinar will be published in YouTube and through LinkedIn. So if anyone wants us to go deeper and maybe show more complex shadows and so on, we can do that as well. So we could, why not have a second digital shadow or webinar as well, if there is interest.
Yeah. We can just shortlist some components that we want to show, and then we can have a physical component on the table, and then we can show how we can make a shadow from scratch as well.
Cool.
Okay, this would be good.
Yeah, but I think it was very clear and easy webinar. So thank you for all the preparation, Raj.
No, you're welcome. I love playing around with Simumatik as always. And tomorrow I'm doing another webinar.
Yeah,
if somebody's interested.
I was going to say that you are having webinars now, and the audience can follow you as well in your channel.
Yeah.
So very interesting.
I'm just solving some exercises on Simumatik. So what I do is I build digital twin of the exercises which are in the book, which is hard to realize. You know, when you have some PLC books, I can show you. I have one of this book. Cool. But you have these exercises with a 2D diagram, and then they write you text. And it's hard to realize in the program is the motivation is very less. So what I do is I try to build digital twin on Simumatik, and then I show it how you can solve this exercise with a digital twin. It's quite interesting because not many people know that you can use the free version of Simumatik as well and connect your PLC. So this is what I'm trying to aware with this webinars, that you can practice.
You can practice a little bit. You cannot modify the models, but you can practice.
You can't create anything, but you can just practice and test some things.
Good luck tomorrow then.
Okay.
And,
thank you.
So
thank you, Mikel.
Thank you, everyone, and see you next time. Bye-bye.
See you next time.
Bye.
Thank you. Bye-bye.